This week on Security Weekly, we interview Ferruh Mavituna from Netsparker to update us on some web application security topics. We're going to do a listener feedback, old versus new in Shadow IT, as well as some fan favorites of general career advice as well. In our stories of the week, I heard that Yahoo had some kind of breach that we'll talk about.
Small one.
In about 3 different or 4 different stories. OpenSSL has a bug. I've got some interesting technology-related articles on Raspberry Pi's new Pixel update to its operating system, and some security stuff too. Thousands of Cisco devices are still vulnerable to the unpatched NSA zero-day flaw. Jack's going to talk about active defense and hacking back in our stories of the week. That is not to be missed, as is the rest of the content on the show, which you're going to enjoy right about now. This is a Security Weekly production. Broadcasting live from G-Unit Studios in Rhode Island, it's the show where exploits run wild, packets aren't the only things getting sniffed, and the cocktails flow steady. It's Paul's Security Weekly. Security Weekly is brought to you by the SANS Institute, the most trusted source for computer security training, certification, and research. Visit SANS.org to explore the full curriculum and latest training offerings. Onapsys, the leading provider of solutions to protect ERP systems from cyber attacks. Customers can secure their SAP and Oracle business-critical platforms from espionage, sabotage, and financial fraud risks. Visit them on the web at onapsys.com. Pony Express. Check out their line of penetration testing devices, including the Pwn Pad, the Pwn Phone, and the Pwn Pro. For enterprises, there's Pwn Pulse, providing continuous visibility into wired, Wi-Fi, and Bluetooth spectrums across all physical locations, including remote sites and branch offices. For all those hard-to-reach places, there's Pony Express. Visit them on the web at ponyexpress.com. Welcome, everyone, to Security Weekly. I'm, of course, your host, Paul Asadorian, broadcasting live from G-Unit Studios in Rhode Island. To my left is none other than Mr. Jack Daniel.
Oh, me. Hey.
I had introductions for everyone, but I don't have them. I collected them.
Right?
I don't have them.
Whatever. It's Jack. It's whatever.
Teleprompter. We're going to get a teleprompter.
Cranky old man.
Yeah.
How the hell are you?
Hey, I'm good.
Thanks for the old-fashioned.
It's pretty nice. Thanks for the bitters. Oh,
yes.
Black walnut.
Black walnut bitters.
Bitters is great.
Mm.
Yeah, it's good.
Yeah.
On the lines via Skype, Mr. Jeff Mann is with us. Jeff, welcome to the show.
Thank you. I've got my old standby Moon Hatton.
Oh, very nice. Those are
the
very
Moon
good.
Dog bitters. If I run out of that, I'm going to be very sad.
I think we ran out of that here in the studio, unless the bottle that you have is the one from the studio. Which
No, I bought 2.
There you go. There you go.
Christmas is coming, Paul.
That's it.
Start making your wish list now.
Geoff Dyer is here with us. Welcome, Geoff.
Oh, g'day, Paul. How are you? Oh, quick. I promised somebody something, so huge, big shout out to Katie in the Black Hills and her dad. Okay, I'm done.
Katie.
Yay, Katie.
Excellent.
Hey, Katie.
Carlos Perez is here with us as well. Welcome, Carlos.
Hey, Paul. Happy to be here.
Yes. It's going to be a fun show. Not much in the way of announcements. We've got some webcasts coming up, and you should go to securityweekly.com/subscribe. All of the shows are there, available for you to subscribe to on all kinds of different things like Google Play and iTunes. Here with us tonight is no stranger to the Security Weekly show, Ferruh Mavituna, the CEO of Netsparker. Welcome, Ferruh. How are you?
Hi, Paul. I'm fine. How are you?
Good, good. It's good to have you back on the show. We always love to have you on to update us on the world of web application security. Before I get started into some of the topics, was there anything specific you wanted to talk about first before we kind of get into it?
No, nothing in particular. Just, We'll follow your lead.
Alrighty. So the first item I had was exploiting a CSRF vulnerability through a MongoDB REST API, which seems to be a growing trend as everything has some kind of REST API or some kind of API. And we talked about this problem like a couple of years ago, but it's still here and still a problem, obviously.
Yeah, it's actually one of the interesting research. It's originally done by one of our researchers, Sven. So he did a very good job. And it's a mix of web vulnerabilities in MongoDB REST API, and a quick story, how all get together. So the cause is basically Mongo REST API only available in developer mode. So it's something that's not recommended to have in production. So you don't expect to see this in production. So you don't expect to see this in an actual website. However, it's quite interesting. As a developer, you have it on local, and chances are it's enabled because it's supposed to be enabled in developer mode. So it makes life easy for developers. And the way it's being exploited, there's a cross-site request forgery vulnerability. But to able to get the data, what Sven used, our researcher, is using client-side timing attacks in web applications. So imagine like you're making a request, and then you expect kind of a response. And if the response takes, let's say, 5 seconds, then it's there. If it takes less than 5 seconds, it's not there. So you can kind of get Boolean responses, true or false, when you ask a question. It's similar how we exploit, Boolean-based SQL injections. Mm-hmm. So the very same idea. So these are local MongoDB, and imagine you have a developer, you visit my website. My website starts this client-side timing attack combined with cross-site request forgery vulnerability, and slowly extracts data from MongoDB, your local MongoDB database. So it's kind of interesting. How realistic is it? It's questionable, but I think it shows that even an application hosted on your local host, not internet facing, if that application is vulnerable, it's still possible to attack that. I think that's dangerous stuff, and that's where the fun is, So you have this vulnerable application, it only lives on your local host, and you might think, okay, I'm safe, I'm good. But you're not. It's still possible to exploit it. It still needs to be fixed. It still needs to be safe. Even if it's not internet-facing application, it's still accessible through your browser.
Is there a way in a client-side attack such as this, and I remember reading about stuff similar to this over the years, but is there a way for me to enumerate to know that application is accessible or figure out where that application is, right? There have been a proven attacks over the years to do that in various ways, right?
Oh, yeah. It's actually very straightforward. You can even do port forwarding over web, which was quite popular, a few years ago, actually, when it first came out. And just checking whether a particular application is installed on a particular IP address, whether it's localhost or you can check, for example, common router IP addresses, gateway IP addresses to see if a router is there. And you can even detect which router is there based on the signatures. And then you can, we know so many routers are also vulnerable, so you can actually detect what is there. Then if you have a list of known vulnerabilities for 15 popular routers, then you can even go ahead and automatically exploit it. And we know some of these vulnerabilities, such as CSRF vulnerabilities in firmware update pages. That means you can upload your own firmware through CSRF to a router that's not internet facing, but only accessible through the local network.
Now, Ferruh, does the same origin policy in the browser protect from some of these attacks? So do you need to have multiple vulnerabilities to bypass same origin?
Same origin works for, let's say, to simply put, if you want to read a page, then you won't be able to, because same origin policy protects you against that, right? So you cannot just, let's say, read yahoo.com from attacker.com. Or you cannot make an XML HTTP request. No. But what you can do, you can include an image from yahoo.com, even if your domain is different. So same origin policy doesn't protect against calling images, JavaScript sources, or making, that's the key. You can make the HTTP request. For example, you can submit a form to a different domain, right? Same origin policy won't stop that. However, you cannot read the response, which where the timing comes in. So you cannot read the response, but you can see how long the response takes. And based on that, you can say, yes, that application is there. It's alive. And as you can imagine, if you block this, almost then the web is broken. If you block embedding stuff, if you block embedding images, JavaScripts, third-party stuff, it's almost the web is broken then. So I don't think it's going to be fixed anytime soon.
That's really cool. So in one of the articles on your blog as well, you talk about exporting Netsparker security scan data to web application firewalls. Now, is this a manual practice, and is this something that you recommend that people do as a stopgap measure, or like what's your recommendation for basically taking the list of vulnerabilities and applying them to web application firewall rules?
What we've seen in our customers and all our users, some of them have 1,000 applications, even more applications. So imagine you are managing security of 1,000 applications. So Netsparker Cloud makes a scan, and the scan takes only a day. You can actually scan 1,000 applications in a day. But now the real challenge starts. As you are managing these 1,000 applications, and let's say you have 10,000 issues. And out of these 10,000 issues, you can say 2,000 of them critical and confirmed. So you have to deal with 2,000 issues. And you can imagine that's the real challenge. You found the vulnerabilities, obviously it's huge, but now you have to fix them, which is massive. And you're not gonna address 2,000 issues overnight. But what you can do, you can actually patch them on web application firewall level until they have been fixed. So as you said, it's more like a stopgap measure, like, okay, fix it for now until we actually solve the root cause of the problem. Because we know web application firewalls are bypassable, it can take time and all that.
Well,
so
that's where I was going, because pen testers will be like, well, I can bypass it. But I think what you're saying is stop the automated scripts that run on the internet that automatically compromising well-known issues from being successful. You can probably get some good protection with OAuth.
It's also defense in depth layer, isn't it? I mean, for example, you're an attacker. Not every single attacker can bypass a web application firewall with a 0 day. Yes, certain attackers with certain level of determination can actually find a bypass, a brand new bypass based on the vulnerability they are dealing with. But you don't expect every single attacker to do that. So you increase the level what the attacker needs to possess to exploit that vulnerability by introducing this. So it's a defense in depth thing. It's not going to save you for a long time, but it can get you some time. And also, someone is just running an automated tool on your website, something like, to exploit SQL injection or, something like that. If they are not expert in what they are doing, if they don't know well, they won't be able to exploit it. So it's still quite helpful. It's still, save you quite a bit of time and maybe save you from a real simple hack, and it will make that simple hack and it will make it very complicated. So it's still maybe hackable, but it's much more complicated now.
Did anyone have questions along those lines to our illustrious panel of Security Weekly hosts? Joff, I thought you might have comments. We talked about pen testing and web application firewalls. Just checking.
I'll throw out a question.
Go ahead.
No, go ahead. Go ahead, Jeff.
And it's not specific to anything we're talking about necessarily, but maybe it is. A couple weeks ago when we were talking to Jabra about the top methods that they had used for compromising a network, I'm curious how high on his list, do you happen to know, Paul, were any web-based exploits?
I'm not sure.
They weren't in the top 5.
They definitely weren't in the top 5. But he was also already on the inside. So I wonder how much that factors in. So I mean, the question I'm asking, that I guess my generic question would be, is how big a deal is this these days to find all these thousands of vulnerabilities in websites, especially when websites very often companies don't even own anymore. They're outsourcing them. They're third party. They're linked to, other third party applications. There's iframes and so on and so forth. Just asking the stupid question, is this still a big deal?
No, I think it's a good question.
I think what I am seeing on the news, for example, Paul is get to it Yahoo hack. I don't know the cause of it. I don't think it's public yet. But what we repeatedly seen, if you look at have I been pwned website where they store all this public hack data, I think majority of that data is coming from SQL injection attacks and various different attacks. So what we see, we got all these websites. We got like Google, we got LinkedIn, we got email. Everything is on the web. And we are seeing all these web vulnerabilities giving the actual impact and making this big, causing these big data breaches. I think we came to a point, web application causing, if not more, but at least same amount of issues where we used to get in network level attacks. But we rarely see nowadays someone found a 0-day on your firewall and exploited, got into your network. We still got that, you forgot that mail server, or you forgot to patch your DNS server, or stuff like that. Or an insider attack, or, malware, phishing, that kind of stuff to find your way into the network. But I think as an attacker who is just somewhere in the world, some random place, want to hack your company, the first place they are looking is your website. And the chances are, depending on what kind of business you are, if you have an e-business somehow, then the important data is on your website or accessible through your website, and that means exploitable through your website. And I don't have any statistics. That's actually something I've been looking at as well. I wonder how many of the current public known breaches happening through web applications, and how many of them are completely network level, non-web app related stuff.
Right. So a follow-up question, just because I'm interested in your opinion. I was having a couple conversations this last weekend at DerbyCon about various things, and SQL injection came up. And I asked the question, how long has SQL been around? How long has SQL been around? Because somebody asked the question, how long has SQL injection been around? And I'm like, well, pretty much as long as there's been SQL. So my opinion question is, why is SQL injection still a thing? Because it's had to have been around for almost 20 years.
Or more.
Or more.
Yeah, that's quite funny. I mean, today, and maybe for the last decade, we got the perfect solution for SQL injection. Pretty much perfect, right? We got parameterized queries, which completely eliminate SQL injection problem. There are edge cases though, right? There are edge cases such as, well, what we do, we tell developers, okay, use parameterized queries. Sometimes they do, and when they do, it's generally fine. When it's not fine, generally parameterized queries do not support dynamic SQL, such as if you want to select the table dynamically, but normally how you do SQL is select star from blah blah where ID equals 10, right? So, and the 10 part is the dynamic part. That's how you generally extract it, and that works perfectly fine. And any competent developer won't introduce a SQL injection in something like that. However, it gets complicated when developer needs to write a code that says select star from and table is dynamic. So they need to get table from parameter or something like that. And that's where it gets complicated because parameters queries generally in many of the languages, I think in all of them actually, do not support that. And that's where you need to write your own security code. So that's something I see nowadays, But another thing, I think we still the majority of the SQL injections are happening because people are not using parameterized queries, people are using outdated libraries, or there is another form of it in recently. For example, that's what happens in Ruby on Rails or ASP.NET MVC in certain cases. You have more interesting cases. As a developer, you are using an ORM, so it can make your life easy while you access your database layer. And you don't know anything. You tell something to the ORM and it works. However, there are like mass assignment kind of vulnerabilities in the past where your ORM makes kind of magic based on the array you supplied, and the actual ORM, the underlying structure, is vulnerable. And as a developer, you're supposed to know that, but the chances are you don't. So more we disconnect developers from the actual code, it's kind of good because we deliver security by default. But also there is this problem if the underlying structure has some weaknesses, even though you documented them, developers don't have the awareness to use the API in the right way. So if you make it easy for them to still use it, they will use it and it will cause SQL injections. To answer your question, actually, I don't have a great answer because in theory, we've got all the protections, all the reasons, all the awareness in the world about SQL injection. Every single developer, if you ask them, heard about it. Yet we still have it. It's all over the place. I don't know how much of it legacy code in production. We see all these hacks and everything. I still bet at least half of it coming from legacy code. And I believe majority of the recently written code in any kind of modern language shouldn't have it because it's actually quite hard to introduce it nowadays. By default, all the application frameworks protects against it.
Yeah,
Well, it's like those developers that are like, yeah, someday we'll do that new object-oriented stuff.
Well, my second comment. Hold on, Jeff. I'm almost done. I'll throw the ball to you.
Okay.
My second comment to what you had said earlier was, if somebody's targeting you, if somebody's targeting your e-commerce site, and I wonder just how many people, how many companies and organizations, they're still relying on the fact that, it's like they're playing the lottery. They're hoping that nobody's really targeting them specifically, or people are, the bad guys are out there trolling, looking for a target, and they're not looking for anyone in particular, just somebody that has a particular vulnerability that they can exploit. I wonder how much that plays into the why this is still such a big problem.
I think that's a very, very good point because if you're an attacker, it's a productivity point of view, right? As an attacker, you got a couple of options. You can pick a target and try to get into it. And the fact is, if you're after money, if you're after any kind of profit, that's possibly not what you do because it doesn't make sense. Why would you, pick one target and focus on it? While it's much easier to get 10,000 targets and find any of them, be vulnerable to the simplest vulnerability that you can find and exploit. So I think from that point of view, what the attackers do actually, pick on the simple stuff. Like, can I just find 1,000 applications and find, 1,000 good applications, like e-commerce applications kind of, and then exploit 10 of them or 100 of them instead of just focusing 2 applications and try to find vulnerabilities in them. Even in bug bounty, I see this kind of smart trend because it's gaming, isn't it? So researcher finds a vulnerability, kind of a different one, which is, kind of a novel attack. And then he or she goes through every single bug bounty program to find the very same vulnerability and starts reporting. Because, that's where the money is. Then you can find...
Yeah. They're first to market. They're first to market. I like it.
Yeah. So it's smart. And attackers are smart. That's what they're after. They're after, as I said, the results. They don't care whether, sometimes they do, sometimes they want to hack Yahoo. Sometimes they want to hack this one particular website for various reasons, right? But your average attacker who is just after making some cash, by any means, they don't care. They will just pick the soft target, softest they can find, go ahead, exploit it, and move to the next one. Hence, that's why we got a massive underground market of selling credit cards, $1 a pop. Otherwise, how can you have that? It should have been much more expensive, right?
I want to do a little trivia. So I'm going to go around to everyone on the show, and without looking on Google or Wikipedia, so don't do that. If you've done that already, disqualify yourself.
That's
What?
it.
What?
Hands up.
You've already done that?
No hands on keyboard.
All right. So,
Hands on soap.
Hands on soap.
SQL or SQL was initially developed in what year? Who can come the closest? Jack.
I don't know.
Looking
Was
for
was it in Jack's lifetime?
Well, that's a really long range. So yes, it wasn't Jack's lifetime.
I'm gonna guess it was probably something outrageous like early 70s.
Okay,
72 also.
Jack.
No clue.
Ferruh?
I will say something like 90 because it should be related to relational databases, I suppose.
Joff?
1989.
Carlos?
Say 91 and you got the future covered, Carlos.
I feel like
85.
Price is right.
That's cheating.
Well, Carlos was 85?
Yeah.
Okay. Jeff is the winner. It was introduced in the early 70s. He actually said
Wow.
it. Early 70s. It was developed by
So-
it was developed by IBM, Donald D. Chamberlain, and Raymond F. Boyce in the early 70s. It's interesting. Relational software, which is now Oracle, made the first commercial version available in June 1979 for VAX computers.
Vax VMS.
Yes.
So,
Wax
so
VMS.
thus proving the fact that Jeff really is very old.
Wait.
It was so good to see you this weekend, Jeff.
Yeah, love you too, man. Actually, I was going to make one comment on SQL injection, and that was, yes, it's been around for a long time, but I think it's Ferruh had a very, very good comment that modern programming frameworks, for the large part, do provide the appropriate protections that developers should not be making these mistakes, and in fact, they have to be very intentional to make these mistakes. However, in pen testing, we see SQL injections all the time, but it's usually in the languages that do not have those sorts of controls and that allow the developers to make the mistakes easily. PHP, for example.
Yeah,
So-
and also to add to that, I see it like crypto. Like people like rolling their own, or they like the new and shiny, and they like coding their own stuff instead of using something that is already existing and proven. I saw that a lot last week at DerbyCon. People going like, "No, I wrote this tool," and they're like, or like 10 other tools that already exist that do that. No, but I wanted to learn. I wanted to do it in Go, or I wanted to do it in Rust, or I wanted to do it this way. And people just like making stuff their own, and many times that's where you actually see mistakes. It's good for learning. It's not so
Right.
good for production sometimes.
No, I think you bring up a great point, Carlos. You know, like I wrote this great program. I'm using Go, and it allows me to search for a character and then replace that character or string. I'm like, yeah, that's sad. It's okay. That's good. Proud of you for that.
That's
but
sad.
That being said,
Nice.
SED. So I want to talk about using Selenium in web application testing. I know a lot of us have used it, and when I did a lot of research into web application testing and tools and techniques, Selenium was a project that really amazed me. One, it was open source. Two, it really helps solve that problem of discovering all of the different parts of the application, which just seems to get more and more complicated every day. So what are the benefits of Selenium, and how do you use it with the crawling aspects of the different products like Netsparker?
The reason we wrote something about Selenium and Netsparker and how they can, work together is we see Selenium is heavily used in QA process. So if you have a website and you can obviously, you cover as much as you can with unit testing. But when it comes to more integration level testing or any other kind of more production level testing, what you do is, you need to test the user interface. You need to actually click a button, see what happens, all that kind of stuff. And it's very complicated. There is no straightforward way to write it like unit test. So that's where the Selenium comes in. You can like capture a macro or write a script and say, okay, go to this page, add this product to your basket. Now click to basket page. Now, change this to this and see if this happens. See if when the user applies this code, see if the discount is applied correctly. So you can introduce all that. So this is just QA though, right? Why is it related to web security? So there is a flow of how things happening in your application. And an automated scanner might not figure out the flow. If you can imagine, it's almost like a halting problem kind of thing. There can be an infinite way to create that particular scenario. And as an automated manner, you wouldn't know that. It's not possible to know that. You wouldn't know that you need to click a button, then go to a particular page, then click a particular button in there, enter a particular code to only see a result and test the security of discount code feature.
It'd be like writing a program that played the video game for you. You have to explore the world in the video game and sometimes do things in order to make things appear in the video game or beat the level, right?
Exactly that. So you need to put the application in a state to reach that particular code branch. And unless you reach it, you won't be able to test it. Unless you test it, you don't know whether it's vulnerable or not. So it's one of the biggest challenges in automated web app scanning, especially from dynamic security, scanning point of view. So Selenium solves that problem. If your QA team already created all these scenarios, then you can just load them into Netsparker, and then the automated web application security scanner can test all those scenarios for you. So it just makes life easier. You already have all these scenarios, just load it up to Netsparker, and now Netsparker can discover all these new features, all these code branches that it wouldn't normally discover.
Yeah, I found it a very effective tool in helping do some of the, well, it's not auto, it's like assisted automated testing, right? When you reach a certain stage, you have to implement these things that, like Ferruh said, reach those other areas of the application, which I think it's important for those who've been in that situation where you're like, hi, I never tested this functionality. And unfortunately, the way you find out you've never tested that functionality is you have a manual test of some kind, and a pen tester or, for heaven forbid, an attacker finds that piece of code that you didn't test. So that's great.
Right.
Well, that never
actually, I want to say something about the previous discussion. Just,
Sure.
I think it's quite important. Something I've been telling for a long time now. We talked about application framework security and how they solve the problem of SQL injections. And we don't see SQL injections that often in applications like many modern application frameworks, but we yet to see them in, older applications such as PHP or, classic ASP. So the point is, I've been talking about framework security, application framework security for a long time now. All these application frameworks, and we got so many more of them nowadays, they should be secure by default, and we're still not there. We had some features, like, for example, CSRF was a big issue. It's much less of an issue because many modern application frameworks got a protection for CSRF built in. So you can just enable, you can just say anti-CSRF true and done, you're good, right? Which is fantastic. But we're still not there. There are just so many other features. They should ship by default, but they don't. And to give you an example, many of these language frameworks, many of these application frameworks, they do have cross-site scripting protection, but the protection is quite limited. It's not context sensitive most of the time. Sometimes technically that's not possible or easy or feasible. Right? But sometimes it is, but it's still not there. So when you don't have context-sensitive cross-site scripting protection, what happens is developer thinks they are secure against cross-site scripting, and they do actually secure if they are writing something, they are outputting something into HTML. But when they do the very same thing within an HTML attribute or within a JavaScript code block, because they don't know framework actually doesn't support that context, and they don't have that much information about cross-site scripting. All they do know, by default, it's secure. But no, it's not, and they have no idea about it. So, for example, if you go around and look at cross-site scripting nowadays, especially in applications like ASP.NET, these are the places you find cross-site scripting. JavaScript blocks, style sheets, attribute, not just your, within paragraph tag or within a table tag, not the normal output, because that's safe by default. And there are just so many other features like that that should have been shipped with frameworks and should have been much more, let's say, secure by default. If you are writing a code in a JavaScript blog, your framework should tell you, look, this is deprecated, or this won't work as you expect in here, or blah, blah. But the bottom line is it should make you explicitly write unsecure code. And you should be aware, like, okay, what I'm doing is possibly not secure, and I should know about that. It's like, when your compiler tells you you are using some unsafe code block in here, or you are accessing memory directly, or stuff like that. It warns you that, are you sure? Do you know what you're actually doing? They should be doing that. They're not yet. And I think we will get there, but it will take maybe another 5-10 years.
Yeah, no, I definitely agree. The protections aren't as deep as they need to be. Ferruh, you said you added something new to the product, and in the alphabet soup that we have in web application security, I forget exactly what you said.
We're just making a release, like tomorrow possibly, or within a week, really. We're adding content security policy checks. So as you said, one of the new additions to web security.
So what are content security policy checks? What is for our audience?
Right. So CSP for short is a client-side protection. It's a defense-in-depth mechanism against mostly, there can be other minor attacks, but mostly against cross-site scripting attacks. What it does, it's actually got a clever way of doing it. It whitelists what you can execute as JavaScript on your website. So, core idea of cross-site scripting is someone can inject JavaScript onto your website. So the solution is, what if we whitelist what can be executed, or where it can be executed from? So to give you an example, CSP is very complex. I think that's part of the problem, to be honest, too. We will see a kind of hard implementation of it, so not much adoption due to that. However, what you can do, for example, you can say, okay, do not allow any inline scripts. So by doing that, you block pretty much all major cross-site scripting issues. And another feature of it, only allow executing scripts from these domains. You can say self, which is your domain, or you can say also google.com, which means I trust any script coming from google.com. But as an attacker, if you are carrying out a cross-site scripting attack, your website won't be google.com, possibly. It will be attacker.com. And even though you can put your cross-site scripting payload successfully, and even though it's been outputted on the page, your browser, if it's supporting CSP, right now Internet Explorer doesn't support it, the remaining do support, mainly Firefox and Chrome, then it won't execute that script. So even though you're vulnerable to cross-site scripting, because of CSP, it won't be possible to successfully exploit that cross-site scripting. But what I said is the real problem. The CSP is quite complex. And to give you an idea, it's a very recent idea, the content security policy. Implementation is been only, I think only about a year or so. And we are already in CSP 3. So even the specification itself is the third big iteration, and they're still changing it.
So the browser has to support it, but the website has to define rules as to how it can operate. I gotcha.
Correct. So what we do now, we tell the user, look, if you are not implementing CSP, it's a good idea to do it. It's like a really nice defense-in-depth feature. If you don't do it, you're not going to get hacked. But if you do it, then you got this extra defense. And secondly, if you have implemented CSP, there are just so many checks. We got about 12, 13 specific checks that can go wrong easily. So you might specify 3 rules, and one of the rules might be overwriting others, making the whole thing pointless. Imagine like firewall rules where you have this one stupid any rule that kind of makes the rest of the rule set pointless. It's the very same idea. So you need like really audit your CSP policies, directives, rules, however you call them, and to ensure that they will work as they're supposed to.
How does it work in a virtual world where web servers might be coming up and down all the time, and it's all cloud-based and container-based and all that kind of stuff?
In that case, well, I mean, what you have right now, as you previously discussed, like there are just so many third-party dependencies.
Right.
So what you end up doing generally, whitelist all these third-party dependencies, right? Okay, I do trust Google, I do trust blah, blah, content delivery network and all that. And you have to just whitelist them if you want to use them. And there are other problems with that actually that people still trying to resolve. Like in CSP, you can block usage of eval functions in JavaScript, which can cause cross-site scripting. But if you're using Google Analytics, and if Google Analytics is using eval, then you have to enable them. That's it. There is no other way around. Either you will stop using Google Analytics. If you disable eval on your website, Analytics won't work because browser won't execute the eval function. And it makes life complicated, but that's part of the problem in web security today. We got so many dependencies. We got so many plugins, widgets, Facebook stuff. You can visit a website, and while we're testing, we see this. We were actually testing one of the websites recently, and we have noticed this one page is doing 300 XML requests or any kind of resource request to so many different places. It's just the design of it. It's not bug, it's how it's designed. So imagine one page doing 300 HTTP requests to just show that one single page.
Right. It's a feature.
It's a feature, exactly. It's a 10 megabyte HTML that's making 300, HTTP requests. That's what web is today.
So are there other features that you've implemented? I noticed some posts on the kind of ticketing and vulnerability management of the vulnerabilities in the web applications and managing the ticketing system. Have you made some improvements there as well?
Right. Yeah, we did some improvements in Netsparker Cloud. So we discussed briefly about web application firewalls and how you go ahead and manage 1,000 applications vulnerabilities. So ticketing is about that the issue management. Now, what you get when you scan a website, you get almost like a to-do list. Because what we had customers, especially if they are new to web security, we give them a report and they just look at the report and they don't know what to do. They don't know where to start from. They don't know, okay, what do I do now? Yeah,
there's all these acronyms they don't recognize, right? Like that's when I look at the report, I'm like, wait, I got to look that one up. I don't know what that one is.
Right.
It's like a Nessus
to-do
report,
list
a
now.
pentest report.
When you scan your website, you got this progress of being good. So you start insecure, depending on how many issues you have, and you got progress like, okay, you fixed 50% of the issues, keep working on them. And because we got confirmation, so we don't have the false positive problem, we know whether a SQL injection is a real SQL injection or not. We safely exploit them to prove they are vulnerable. So now you actually got this very solid progress. And if you complete the progress, you are secure as much as an automation can get you. And I think, though, one of the really, really good features that we are still developing, and it will take a couple of months to, actually publish it, is we are building this new feature. We are adding some checks for server-side request forgery issues. But with that technology, we are now shipping a DNS responder. So, which will allow us to test all kind of blind cross-site scriptings, blind SQL injection, blind anything. So, because if there's a SQL injection, imagine, we talk about SQL injection, but imagine this particular scenario. So, you are pen testing an application, and you send a SQL injection attack. Okay, no response, no time difference, no page difference, no error message, nothing. So you say, okay, this is probably safe. You don't get any feedback. And then what you send is that midnight processed by another server. So every single line of the data you have sent, processed by, I don't know, some invoicing server, logging, aggregation, whatever it is, right? And then there's a SQL injection in that server. You would miss that, right? It's not easy to catch that because you're not testing that. It's completely another server.
I remember reading about this attack actually a little while ago.
Right?
This particular attack vector, yeah, it's very interesting.
So what we added now, we got these listeners, which is internet facing, and we will ship it as a Docker image as well. So you will be able to have a private version of it. And then when that SQL injection gets triggered, through DNS, we thought it's the easiest way for exfiltration to bypass lots of egress filtering stuff. It will report the SQL injection to the DNS server that we shipped or you shipped privately. And then the scanner next time come around, or in Netsparker Cloud dynamically all time around, it will say, okay, I found a SQL injection on a scan that you done yesterday or this morning. After 10 hours later, I've noticed this. And the very same idea applies to cross-site scripting. Imagine you made a cross-site scripting attack, and that night, an administrator in the control panel in an application that's only accessible in that, behind a VPN or in a private network, visit that command that you submit through the website. And there's a cross-site scripting that administration panel. And then the cross-site scripting will make an HTTP request or DNS request to our listeners and say, okay, I just got triggered, and here is the URL. It will give us the URL and some pieces of information to get an idea where it got triggered. So this is what we have been building, testing, and this will apply to so many vulnerabilities, including code execution issues, SQL injection, cross-site scripting, server-side request forgery, every single issue. So it will be like a new generic technology for Netsparker to improve all the relevant checks.
I think that's super cool. I'm super excited about that feature active because I remember reading about that attack and thinking about how difficult it was to test for those attacks, not just from, yes, I'm scanning my own web apps, from a pen testing perspective as well. It's sort of like you compromise the system and wait for it to come back online, and you have to have a listener running. So I think that's super cool.
That's another thing. I mean, as a penetration tester, manually testing a website, it's still very complicated, let alone for an automation. But even if you do it manually, you need a listener. It's very complicated. You don't know when it might get triggered. So you need to have a listener, notifier, and all that. There are, I think, a couple of open source projects to have like something that practical. And I definitely know one for cross-site scripting. I can't remember the name though. But yeah,
that's the one I think I was.
Testing,
that's the one I think I was reading about. Someone had sent it to me and said this is a cool attack, and it was that open source project that did it for cross-site scripting.
I think Netflix. I think Netflix researchers, they published something like Blind Puppy. If I'm not
something
Blind Puppy, right? Yeah, that was it for cross-site scripting.
Yes. Yeah. Well, awesome. Any more questions for Ferruh? Well, sweet.
Good.
So I'm assuming people can still get a free trial of Netsparker Cloud. Is that correct?
Oh, definitely, that's correct. Especially if they mention Security Weekly, we will express it.
There you go.
Nice.
You get Security Weekly listeners get special treatment. It is a product that I love. We've used it here at Security Weekly. I think it's great. I've done a lot of web app testing. In fact, I had a huge project where I was testing all kinds of different web technology, and it's one of the reasons why Netsparker is a sponsor, because I really like your technology. So, and we love having you on the show, Ferruh. So thanks for joining us. It was wonderful having you.
Thanks a lot, Paul. It's always fun to join. Thank you.
Excellent.
Enjoy talking to you, Ferruh.
With that, we're going to take a short break and talk about listener feedback. So stay tuned.